ConvertPLUS ARE is the tool where we take all of the Gerber data and the drill that we've created thus far, along with the component centroid, and build everything up to create a functional simulation of the circuit board. So first, we simply go to Import Wizard, and we locate a directory containing all of our outputs from the previous process. And again, that includes Gerber and Drill. And we go ahead and import those. Now ConvertPLUS will automatically recognize the file types and stack the layers up accordingly. All we need to do is we need to come into Setup and define what the layers are. So for instance, we'll call this the top silkscreen, mask top, top layer, stack up a couple of inner layers, and I think this is the bottom, mask bottom, and the border. Once we've done that, we need to go set up any blind buried layer sets that we have. So we'll create a new layer set, and we'll call this 2 through 4, and toss in our buried drill layer and the corresponding circuit layers. And now we have stacked up the board, and we can actually go in, if we want to, and generate a netlist and start probing different nets and seeing what lights up. So we'll go ahead and do that real quick. Now to simplify, I'm just going to show the top circuit, and I can come in and query net and select any one of these features and identify what's connected to it. So for instance, I can change my highlight color to purple and select this via, and I can see all of the different nodes of that net on this layer. And I can also trace that throughout the different layers of the circuit board by toggling on and off the different layers. So that's an aside. You don't need to do that for the process, but it's just a demonstration of how the circuit board is now being fully simulated electrically. So the next step is I need to import my component centroid information and identify the pins that are associated with each component. And that's again very simple. Run the function, identify our input file, and it's going to jump to a component that it found. So here it found IC1. I'm going to select the pins associated with IC1 and go ahead and program the part. And then it jumps to IC4, select the pins associated with IC4, and so on. And we just progress through the board identifying the different pins for each component. And it's important to note that you don't need to do this for every single component. So you'll notice that I only programmed one of these LEDs, but if we zoom out, you can actually see all of these LEDs have been identified. And you can tell by the little pin number. You see pin number 1 and pin number 2. So once you identify one of a given part, it will go around and program the remaining parts that match that footprint. So even for the really major PCBs that have thousands of parts, it doesn't take very long to do this because you're just programming unique components. Just a handful more to do. And we're done. Now the last thing is we want to go in and modify some of the pinouts, because you'll see, like for instance, IC4, this pinout probably isn't correct. So all we need to do is right click, go to Open Set Pins, and we're just going to set a different pinout and hit OK. And now you can see the pinout matches what you would expect for IC4. In addition, we'll go do the same thing for IC1. And now that's changed. Additionally, we can actually rotate any components just by right-clicking. So for instance, on this diode, I can right-click and, oh, actually that one only has one instance, so I can't rotate that diode. But what I can do is I can rotate something with multiple instances, like this capacitor. Come down and rotate it, and you'll see that it'll just flip the pins. So you have full control over how the pins are programmed, and again, you can see it's a very quick process. So at this point, we've programmed all of our parts, we've stacked up all of our layers, and we have a complete fabrication data package that we can send off either in ODB++ or IPC 2581. If we want to move on to schematic, we can export an IPC D356 file, combine that with our bill of materials, and generate PDF or native schematic formats.